Hello and welcome. In this tutorial, we are going to begin with programming. We'll be taking a simple, humble little LED here and making it blink using an Arduino program. Now, let's get into it. You will notice, however, before we even start, that there is a blinking LED on the board right here. I'm pointing at it. And that is a sort of native LED that exists on Arduino. I believe it's tied in with pin 13, even though you can access it via saying like onboard LED or just calling out pin 13. So first of all, I may just try to get this guy to blink at a different rate. So let's start a little program. We can call an LED. We can start by declaring it, call it LED on board equals to 13. So from now on, every time I say LED on board, the Arduino is going to receive 13. And so we can say pin mode. So we can either write 13 output, or instead of 13, we can use LED on board. Now, LED on board, in a way, is easier to read if someone else were looking at our program, so we're going to do that. Then we're going to digital write LED on board, comma, high. Delay, and we're just going to make it blink fast. We're going to delay, I don't know. Actually, let's just go something big. 2 seconds, delay 2000. Then we're gonna basically repeat this code, except we're gonna make that low. So it should blink even slower once this program is uploaded. Arduino Uno, port that one. We're just gonna save it as today's sketch. And there it is, blinking more slowly. And now we can just try this out. Very interestingly, this is the only pin that can be, where you can use an LED without a resistor. There's also a resistor inside pin 13. So if we get the long leg inside pin 13, in fact, I'll be looking at the camera here for guidance. 8, 9, 10, 11, 12, 13. If we get this guy in, he won't burn up. And see, these two are on at the very same time. So, in fact, I think getting a little bit of resistance and getting this guy to be a bit more faint could also work reasonably well. So I guess I can just get a cable into 13, 8, 9, 10, 11, 12, 13, 10, 10, 10. Get a resistor in there. So right now the resistance is like 400 ohms. There it is. Still pretty bright, but at least right now we can see this little guy right here. He's not obscured. So I want to do a little bit of an experiment. And the experiment is this. I would like to try to get this light to blink so fast, or find out the exact rate at which it's blinking and we don't notice it. So this here being milliseconds, we can try, obviously at 2 seconds we notice it. We can try 1,000th of a second. Dun, 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 dun. Yeah, I definitely can't notice that blinking. So that's a speed too high. Now let's use this to discover the sort of number of blinks per second. That is like the refresh rate of the screen you're looking at right now, which is either 50 blinks a second or 60. So let's declare an integer and call that frame rate. and make that 0. Actually, I'll have a think about it. So the delay here should be like 1,000 divided by frame rate. So let's say something is meant to happen 60 times a second. However, that event takes place in 2 of these delays. So we actually are going to have to make that even faster. So let's think about how long this blink takes. A blink is a light on and a light off. So this whole blink is going to take 2 portions of this. So basically in, 60 turns, this whole thing is going to happen in 2 seconds. And we want 60 blinks to happen inside 1 second. So I need to divide it like that, 2 times frame rate. 2 times frame rate. So let's test this out. So frame rate is right now 0. Let's try frame rate, something that we should be able to see, 5 blinks a second. Let's see if that actually works. I believe that this isn't 1,000 divided by 2 times frame rate. I think that this is 1,000 divided by 2 times the frame rate. So that, let's have a look if this was a BudMass issue. Let's try that again. We should be looking at something like, yes, that looks like 5 blinks a second. That looks believable. So if the screens happen at, 30 a second is already something reasonably fast for the human eye. Pay attention to this. That is fascinating. That is fascinating. What you guys are seeing right now, because this video is being recorded at 30 frames a second, is a really slow blink. I'm looking at it on the screen right now, but what I am seeing is a light blinking so fast I can barely perceive the blink. Let's see what happens if we go frame rate 50. Yeah, I can't tell. However, you can. Again, this is a very, very interesting effect. What you're seeing in the video screen and what you will see when you put this program in are 2 different things. I cannot perceive any blinking whatsoever, and the screen actually, like I'm looking at the video footage, the same video footage you guys are seeing, and you can. So this is an interesting tutorial in a sense that this would even be different for individuals. So at 40 I can perceive perhaps some type of vibration. I wouldn't even be certain if this is blinking. At 30, I can perceive vibration. And at 25, I can definitively tell that it's the LED is blinking. So this little experiment, which is going to look completely different to you when you're actually looking at an actual LED as opposed to the screen of a camera that's recording in 30 frames a second, you're going to discover at what point you begin to perceive the blinking. And sort of the universal threshold where pretty much everybody cannot perceive blinking is at 50 frames per second. So there you go. Do this and have fun with it.